Okay, so today we're doing section P4, which is on polynomials. So the first thing is, can you recognize a polynomial? And I know that definition up there is kind of overwhelming, but what's important is what's here in yellow. So a polynomial is a string of things added and subtracted. And so these a sub whatevers just represent coefficients, and these x to the n's or x squareds just represent variables. So a polynomial, the rules for something to be a polynomial is that you have to have whole number exponents. So your exponents have to be things like 1, 2, 3, 4, 5. No variables in the denominator, because that would imply a negative exponent. And you have to have real number coefficients, which only leaves out imaginaries, which we're not really dealing with right now. All right, so some other things to keep in mind, just some terminology. Remember that when you have a polynomial, like this is a good example of a polynomial, so is this guy right here. All right, so you've dealt with polynomials before. They're not as scary as this definition up here makes them look. All right, so if you have this polynomial, it has 1, 2, 3 terms. The leading term is the one in front if it's in standard form. The constant term is the one without a variable. All right, so standard form, I just said that. What that means is that you have descending powers. Your exponents are in descending order, biggest to smallest. So if I have this, if I want it in standard form, I should write it like this, so that the biggest exponent to that term comes first, and then you follow suit until you get down to the constant. All right, so polynomial, we're only going to deal, no, that's a lie. I was going to say we're only going to deal with polynomials in one variable, but we'll probably deal with multiple variables. But anyway, polynomials are nice and friendly, honestly. I'm not going to have anything too crazy going on. All right, so the first thing you're going to have to do is tell me, is it a polynomial? And you have to be able to write in standard form and give the degree. So remember that degree is just the biggest exponent. All right, so this first function that we have, is it a polynomial? Well, does it have real number coefficients? And the answer to that is yes. There's an understood 1 and a 3. Those are real numbers. Does it have whole number exponents? So you've got a 3 and an understood 1. So yes, it's a polynomial. It's already in standard form because it goes from an exponent of 3 to an exponent of 1. And its degree is 3 because that's the biggest exponent. All right, so number 2. Looking at that, is that a polynomial? Well, it looks okay until you get to the end, but x as an exponent is not okay because x is not a whole number. I don't know what x is. So this is not a polynomial. I don't know why I didn't just write the word no. All right, so number 3. Do we have a polynomial? Well, he looks okay, except that he breaks the rules right here. So this is also a no. That is not a polynomial. Number 2, in case you didn't catch it, broke the rules because of that guy right there. All right, number 4. This one looks a little iffy, but pi is a real number, and so is the square root of 2. We have a 1 as an exponent, and we have a 2 as an exponent. So this is a polynomial. To put it in standard form, we need to make sure that the exponents start from the biggest and go down from there. So the biggest exponent is the 2. So we'll have pi x squared first, then the negative 0.5x, and then that's the square root of 2. All right, and then the degree of this one, the biggest exponent we see is, mercy. See if I can write. There we go. The degree is 2. The biggest exponent is 2. All right, so the first part of your assignment will be, is it a polynomial? So those are yes or no questions. The second part is, what is the degree? So you're just picking out the biggest exponent. After that, you will be adding and subtracting polynomials and then multiplying polynomials. So adding and subtracting is just a matter of combining like terms. If it's addition, You just pretend like the parentheses are not there and combine any like terms. So we have this 9x to the fifth. There's nothing over there that matches. There's no x to the fifth. So we keep 9x to the fifth. We want our answer in standard form. So when I collect my like terms, I try to make sure that I'm going in order. So the next biggest exponent that I see is this x to the fourth. And there isn't an x to the fourth over here. So we just have 6x to the fourth. All right, the next exponent that I see is x to the third. And we have one of those in both, so we're going to combine those and have 2x to the third. And then you have this x that has nothing to combine with, and you're done. All right, so number 6, that one is subtraction. We know because there's a minus sign between our two polynomials, between those parentheses. The easiest way for most people is to remember that you have the distributive property that says we can give that negative to everything behind there, which just changes those signs. So now it is just a matter of combine your like terms. So this 8x to the third does not have a friend to combine with, so we write it down. The next biggest exponent is a 2, and he also is lonely, so just write him down. All right, so then we have this and this that match. So we have 5x, and we have a minus 1. All right, so number 7, I would say that maybe you should pause and try this one and then unpause and see how you did. All right, so the first one stays the same to start. We distribute the negative, which changes the signs of the things in the second parenthesis. And then we combine our like terms. So you have this guy and this guy that have matching variable parts. So 4 minus 3 is one of those. You can write the 1 or not, if understood. Then you have the 7xy that doesn't have anybody that matches. And then we have a negative 2 and the negative 8, which gives us negative 9. All right, so that's adding and subtracting. So multiplying. How do I know I'm multiplying and I'm not adding or subtracting? Well, with multiplication, your two polynomials will be in parentheses, and the parentheses will be touching. There won't be anything in between. No plus sign, no minus sign. All right, so the way that we multiply polynomials is we distribute everybody in the front to everybody in the back. So 5x gets a term. He's going to multiply by both of these terms. So 5x times 3x is 15x squared, using those exponent properties that we learned the other day. 5x times 7 is going to be 35x. All right, so now it's negative 8's turn. He has to distribute. So you get negative 24x when you do negative 8 times 3x, and you get negative 56 when you do 8 times 7. All right, so then you're going to combine your like terms. So let's see, this x squared doesn't have anybody that matches. But when you look at these guys, you can put those together because they're both just an x. So 35 minus 24 is 11. And then keep your negative 56. And we're done with that one. All right, so number 9 works a lot like number 8. You're just going to distribute. I'm going to change my color so we don't get too overwhelmed. Things start running together. So we get 8x squared times 8x squared. So 8 times 8 is 64. X squared times x squared, add those exponents, you get x to the 4th. Then you do 8x squared times negative 5. That gives us negative 40x squared. Now it's 5's turn. He has to distribute. So we're going to do 5 times 8x is 40. 8x squared, sorry, is 48. Start over. 5 times 8x squared is 40x squared. All right, so then we have 5 times negative 5 is negative 25. When you go to combine your like terms here, you see that these guys match except for the sign, so they make 0. So we just have 64x to the 4th minus 25. Now, if you look at what we have in the first place, these are conjugates. We learned about those the other day, how they're exactly the same except for that sign. And when you multiply conjugates, we know that we can do just the front times the front and the back times the back. So when you're doing this, you can jump straight to this answer and skip that. But if you don't remember and you do all the math, it's still going to work itself out. All right, so number 10. Same thing, everybody in the front to everybody in the back. So 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. And 2 times 2 is 4. Combine those like terms, and we get a 12x in the middle. All right, so this one is another one that's a special case. If you see that we multiply the exact same thing. So this is the same thing as if they asked you to do this, which they will on your assignment. So they give you a parentheses squared. This plus sign makes it to where we can't just distribute that exponent like we did when we were doing exponent properties. So what we have to do when we see something like this is literally write it down twice and do all of the distributing. Now there's a shortcut, if you can remember it, when you see that you have something like this, to jump straight to the answer, you can square the front, square the back, then you've got to multiply those terms together and double that number to get that middle term. And again, if you don't remember the shortcut, that's really okay. Just work it all the way out. All right, so now we have these long, ugly ones. It doesn't matter how long and ugly they get, you're still doing the same thing. So we're going to take everybody in front times everybody in back. So 2x times x squared is 2x to the third. 2 times 1 is 2. 1 plus 2 for those exponents is 3. All right, so now 2x times negative 3 is negative 6x squared. And 2x times 6 is 12x. All right, now it's negative 5's turn. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 3x is positive 15x. And negative 5 times 6 is negative 30. All right, remember always try to combine some like terms. So 2x to the third is the only thing to the third. We have a negative 6x squared and a negative 5x squared. That gives us a negative 11x squared. We have a 12x and a 15x, which gives us a 27x. And then your minus 30. All right, let's see. I'm going to move this down and work number 12 down here. See if I have, I'm not going to fit it right there, I'm almost positive. All right, so I'm going to work this problem like I'm going to start it down here. Okay. All right, so we're going to do 9xy times 2x squared y. So 9 times 2 is 18. I'm going to run out of room. I got to scoot over. I know it's 9 times 2 is 18. X times x is x. X times x squared, sorry, is x to the third. Y times y is y squared. Now 9xy times negative 8. 9, I keep losing half of my numbers, y'all. I'm sorry. 9xy times negative 8x. So 9 times negative 8 is negative 72. X times x is x squared. And you have the y. All right, so now 9xy times 5y. 9 times 5 is 45. You have the x, and then y times y is y squared. Remember, when you're multiplying like that, we multiply the like pieces. All right, so now it's 5y's turn. So 5y times 2x squared y. 5 times 2 is 10. You have x squared, y squared. Then 5y times negative 8x. 5 times negative 8 is negative 40, and you have an x and a y. And then 5y times 5y. 5 times 5 is 25. Y times y is y squared. All right, so now we just combine our like terms. So nobody else has an x to the third, a y squared, so we just write that first term down. Looking to see, do we have an x squared y? I do not see another one. Actually, if I'm looking at this, I don't see any terms that are the same, so I can skip that combining like terms step because I don't have any like terms. Because he definitely doesn't match. This is close to this, but not quite because they're not both squared. And it's close to this, but not quite because the x's are not squared. So we don't have any like terms. We're done. Okay, so that's all of the examples that I have. Again, if you need more examples, if you need some help, please let me know. This is the assignments. I'm happy to answer your questions, make another short little video if you need some more examples. Just make sure you reach out.